Thank you for the invitation to come here. Yes, we will talk on mineral resources. Just the first slide. In fact, my main job is working on the formation, on the genesis, on ore deposits, and a lot of in the Andes. But I have been involved in this topic for several reasons. One of them you will discover now. So we have heard a lot on the evolution of market growth for several metals. And I would like to look here, that you look between 2001 or 4 and 15, the GDP for the world is grown 41%, but of China, almost 300%. And that, of course, we have heard that many times. And that had explained the main growth of the use of all these metals. For example, copper, 155%. I have put in red some of the metals we have been talking along this talk. We have to think, we know that the China population is not increasing more. Growth, prosperity is still increasing, but they will reach a plateau in the consumption of minerals. But then will come India. Actually, India is already there almost, and other countries. So we, as has been said many times, we will need more metals. In this slide, you see that even if we would recycle all the copper has been produced, we would need for the next 26 years to mine the same amount of copper that has been mined so far. In addition, is the low carbon change that we will add new needs. For example, if 100% of the vehicles became electrical by 2050, what probably is not the case, but perhaps yes, we will need 22% more copper, more nickel, of course, 3,000 times more lithium. I have ordered this slide according to the approximate market value. And you see copper is on the first place. And copper is a very important metal also for climate change, of course. So it's copper, nickel, neodymium, cobalt is already much, much, much smaller than copper. Lithium is still ridiculously small. It can change in the future, but it's still small. Indium, the whole production of indium had a value for less than $500 million for the whole world. Germanium, niobium, gallium in the same order. We have, yesterday in the talk by Karen, we saw that some critical raw materials, the demand of these materials will dramatically exceed current production in the next 10, 15 years. That's absolutely correct. Limited access to these materials might negatively impact the transition that we would like to have. Now the question is, how limited are we? For that, we have two levels of discussion. First, for how long do we have metals? The answer, no risk of exhaustion in the future. I would like to be there very categorically. There is no risk. However, no geological risk. However, there are certain risks of temporary supply shortages. This is not the public perception. Public perception is that we are running out of metals. I downloaded that yesterday from the BBC. According to this BBC, that is the best media in the world, we are running out of indium in 12 years, antimony in 8 years, copper in 32 years. Well, you will say, well, that is BBC, that it's not scientific. In high-impact journals, you see similar things. You can see, for example, the extractable ores of the world geological are scarce resources. For example, antimony, molybdenum, and zinc may be exhausted within several decades. You can see this table where it says that, for example, zinc will be exhausted in 50 years, antimony in 10 years. Even in a paper like Science, you can see similar things that copper will pick up. Why is this perception not only of public, but also of scientists? Not all, of course, many. It's ridiculously simple. Most alerts are just wrong and essentially derived from a confusion between resources and reserves. 2 years ago, there were publications in this journal, Geochemical Perspectives, saying more or less the same, that we are running out of metals, that we have to change our model of society. Perhaps it's a good thing to change the model of society, but not because we are running out of metals. So several colleagues and mine, we wrote this long paper, it's 170 pages, that you can download in open access on the future global mineral resources. The summary is that we have mineral resources for countless generations, if enough exploration and if enough skills. Some of the slides that I will show are coming from this paper. So why this confusion? Let's look on the lifetime of some metals. Let's start with copper. You see, in 69, the lifetime, that means the reserves divided by the consumption, that is more or less equal to the production of each year. So in 69, the lifetime for copper was 51 years. Today is 40 years. In between, we have exploited immense amounts of copper. For zinc, more or less the same. It was 16 years in 69, it's 17 years now. Why is that? It's easy, because reserves is the amount of resources that have been measured, found and measured. And this is very capital intensive. So companies only define reserves, the reserves they need. And they need more reserves for big mines, like, for example, copper mines, than for zinc mines, that are smaller mines, or gold mines. That is the reason that, for example, zinc appears in the statistic that is almost exhausted. It's just because the mines are of a smaller size. It's not because we have less zinc than copper. In fact, it's the contrary. We have more zinc than copper. For all metals, the same thing. You can say, what did happen in 81? In 81, we had the oil shock some years ago, and several public organizations and governments subsidized exploration so that not to depend on developing countries on mineral resources producing countries. The result, as you see, is that the mine life growth was much bigger. For example, of copper, it was 72 years, for zinc, 40 years. This was extremely bad because, of course, metal prices went down, exploration collapsed, and, of course, recycling also collapsed. That is what I have explained. So, okay, but metals are not renewable. How far away are we from a peak copper or for other metals? We have seen this slide. Almost all ore deposits have been found only in the first 300 meters of the surface. We know from the geological point of view that below 300 meters or 500 meters, there are also deposits. There is no geological reason that not to have deposits. Let's look a little bit better in the detail this slide, because you will see some big deposits there, how they were found. It's very interesting. These deposits, they are copper deposits, Greenfield. Greenfield means in areas where there is no mine. They were found because of hydrocarbon exploration. So they were not found looking for copper, they were found looking for hydrocarbons. That was the reason that these big deposits, deep deposits were found. The other ones are deep, but are brownfield. So they are the continuation of known mines. So in summary, what we see here in this slide is that there's a huge potential to find new deposits. Of course, this will be difficult, but the deposits are there. Steve Kessler and colleagues have calculated how much of these deposits would be there. And they came to the conclusion that they are, for example, for copper, 2,500 years of deposits with the same grades that we are exploiting today. Not low-grade deposits, but the same grades with using the same metallurgy. And as has been, Tracy was mentioned before, metallurgy is a very important process because there is where most efficiency processes have been done. And beyond, if we have found all deposits until 2,500 meters or 3,000 meters, how about mining really low grades, for example, between 200 and 200 ppm of copper? Are there deposits? Well, there is already one deposit in Sweden, Aitik, the porphyry deposits, where they are mining almost at this grades, less than 3,000 ppm. We have to look at that I won't show these slides. And yes, there is a huge potential for low-grade deposits, low-grade mineralized rocks. So in summary, for example, for copper, I take copper as example because we have seen from the economic point of view is the most important and also for the energy transition. So we have, that is the reserves. This would be the geological resources which have not been found according to a study of USGS. This would be a model-based deposits, thinking what happens with plate tectonics, with deposits that have already formed, would be a much larger volume of copper. And this, if we are able to mine low mineralized rocks after 2,500 years, if that was the case. Of course, this has energy consumption implications and all kinds of implications because we would need more energy. On the other side, it is possible there are also some implications, some metallurgical progresses. At this point, I would like to say two things connecting with the past talk. In fact, these deposits wouldn't only be economic if metal prices increase. Metal prices is very strange what I will say to you now, but metal prices have not increased historically. Actually, we have lower metal prices than in the 50s. And of course, lower metal prices as in the beginning of the 20th century. Metal prices are cyclic, they come up and down, but the long tendency is that they have to decrease. We would be very happy, especially geologists working in exploration, if metal prices increase in the long term. Also, we will be very happy from the environmental point of view because this is the main driver for recycling. But we are not there. It's very strange. So we cannot say metal prices, we have to mine low-grade, we are mining low-grade deposits, but not because the metal prices are higher, but because the efficiency in mining, in the whole mining chain, is much higher in the mine and in the metallurgy. This has allowed, as Tracy has said, that to mine low grades. So this means business as usual? Of course not. There are a lot of problems. One is here, acid mining drainage, that in continental deposits, perhaps not in seabed, it's a huge problem, because in seabed, perhaps alkaline water prevents of this problem, or mitigates. So we have multiple challenges. We have new needs. We need an exploration effort, because of course, to find deposits deeper or in areas that haven't been explored now, it demands an effort. This means land access, and for that, we have key issues like environmental impact, social license to operate, not in my backyard. Economics. That's a tricky thing, because metals have a cyclical nature of prices, so that the companies try to invest when prices are high, because they have cash. But when the prices are low, they stop investment. It's not logical, but that is like the business works. And since there is a long-term business, often the exploration is not as efficient as it should be. Then we have another problem, that certain green materials have niche markets. That is an important thing, because these niche markets prevent many companies to enter them, because they can be controlled by 1, 2, 3, 4 players. Vertical integration, we see that with lithium. From Toyota, from the Salar in northern Argentina to Toyota or Volkswagen directly. No transparency on the market. Again, a barrier for investments. Lack of transparency, as we're saying. Many of these new metals are byproducts of other ones. There is also another risk, substitution potential and technology changes. Who knows if lithium will be important in 20 years? Perhaps, even I would say probably, there will be other more efficient ways of store energy. In addition, increasing undercover and deeper the deposits that we will have to find, we need excellent geoscience skills, science, technology, education, training, things that have been said before. We have seen this slide many, many times. I wanted today in this conference, or something similar. Originally, it's from the VHMS. When we are talking of all these elements, remember that some of these markets are so small. For example, we have smartphones. We have to have small smartphones to follow this session, we have heard. And we have tantalum in these smartphones. The whole market of tantalum, it's less than $250 million per year. Very small. And I could put other examples. Lithium. That's very interesting. Lithium production has increased. We hear a lot of lithium, but it's still very small, 43,000 tons, compared to the resources. You can see the resources have increased. How it is possible that the resources of the world increase? That is not reserves. That are geological resources according to USGS. Just because the knowledge has increased, and now we are seeing there are other possibilities. To put an example, here you see that the resources in the world, according to USGS, have been multiplied by 4 in 20 years. For the US alone, it has been multiplied by 7. In 1905, they thought they had 1 million tons of lithium. Now they say they have 7. The same thing will happen in other parts of the world. So probably there's no problem, even if we would really need half a million of tons of lithium per year to make all cars in the world electrical. Even in this case would be probably enough. Follow the money has been said. Look, even it's a lot of talking on lithium. The investment is very shy. That is lithium budget for exploration that has increased, but still it's at a low level of investment. The same thing for cobalt, even if we know that we will need that. So many of these green metals are in these parts of this scheme: modest market, small markets. And these control also exploration, because this increases the risk. And follow the money. People with money don't want the risk. The other thing is, of course, byproducts. For example, indium, germanium, cadmium depend on the production of zinc and so many other elements. So in case that we would really need that, the price, some mines would be more economic. Environmental impact, social license, that's really a key issue, and we will hear probably more in the next talk. We need not only better mining exploration practices, because mining has really a bad record of impact, environmental and social impact in many parts of the world. And we need the public engagement. And for that, we need transparency, trust, also sharing benefits and burden. Also mining in Europe for many reasons. And at the end, we need really, yesterday was discussed about the politicians. In fact, the politicians will follow the public. So we need public engagement of local communities, but also society at large. Deeper, undercover, cleaner. So we need more science, more technology, more skills. It will be it's not an easy task. It is getting increasingly difficult. We will not only to find the deposits, but also to find deposits with smaller footprint. I would like to say another thing. Actually, in this moment, the ideal mine is not a superficial mine, but it's an underground mine, because it has not footprint, much less footprint. That is the ideal mine for big companies. We have to look for new geomodels to find these deposits, and at the end, really skills, including basic geological skills. And this, I'm at the university, but at the same time in exploration, I'm seeing it's a big problem, because the geologists in the field have a lot of machines, a lot of portable instruments, huge amounts of data, and they don't cope with the data they get. And so at the universities, we'll have some progress to do on that. Conclusion, from the geological point of view, mineral resources will not limit decarbonization. Yet, some risks for supply bottlenecks we have seen. Social license, I put that on the first, because really on the ground is the first problem we have. Lack of exploration investment. In the case of these materials critical for industry, and deposits undercover, deeper. We need more science, better skills, increased public knowledge on what we are doing. Thank you very much.
It was a very clear message you gave at the end. I learned a lot. So, any questions for Lluís? Yeah.
Thanks, Lluís. It's really good to hear. As a minerals geologist myself, you get us, when are we going to run out? I think just an observation, really, that it's the message, you're right, we need to give everyone that message that, you know, the Earth's crust is a big place and there's still a lot of metal to be found. I think we need to get people to worry about the right thing, not the wrong thing. And what I worry about is the environmental consequences of us working those metals, because you and other speakers have said the carbon intensity of primary metal production is enormous currently. The biggest desalination plant in South America provides water for a copper mine up in the high Andes. The desalination plant is on the Pacific coast of Chile, and then they pump that water uphill for 3,200 meters.
Escondida.
Escondida. It's a huge amount of energy just going into making that water and moving it. And that's what we need. We're going to reach the environmental limits of the planet far sooner than we reach these physical limits.
Yeah, we are not. Yeah.
And that's a really important message for kind of...
Yeah, absolutely, Eric. I agree completely. It's the same thing as with hydrocarbons. We cannot afford to use all our metals.
No, we don't. No.
Just to clarify again, obviously there's the technological advances, you've got the economic value, so obviously you're going to revisit sites and perhaps look to extract where you wouldn't before if the market calls for it. Is there any potential, do you think, for companies to have more onus put on them to look at research and development for their wastes in the form of perhaps kind of additional taxes by not doing it to encourage them to use more of what they're taking out? So although they're looking for one specific thing, the byproducts that they've got, to actually do more research and development at that stage, whether it's perhaps utilising, I don't know,
I think
educational facilities in areas to perhaps run it internally with students who are then going to go into the markets.
I think absolutely the companies are intrinsically interested in that because they are looking for benefit, and all the things that you have mentioned, they suppose risks for them. There are multiple examples of projects and operations had to be cut, stopped, because some of the reasons that you have explained. But at the end, that is one of the reasons that I was saying it's also important to do mining in Europe, because we can keep some certain standards. By the way, I would say in many, as it has been said now in many mines in the Southern Hemisphere, for example, Latin America, have the highest standards as you could have, for example, in Canada, but others not. But many, they have. So it is possible. The problem is we need the political and the social pressure to keep these standards. At the end, it's a political problem and governance problem in many places. It has been said, Francis was saying, one of our problems, there is no an added value for companies that are working well. They sell the same price. That's now the largest producer in the world is Codelco in Chile. And they are trying to do that. They are trying to sell so-called green copper. When it is controlled, that it is done in the way that you are saying, a little bit more expensive. It depends on us, the consumers, if we buy that or not.
Yeah, one more question? Comment?
A follow on to that, because you talked about the direction we like the bigger companies, the well-regulated companies to go in. But in parallel, we heard about illegal mining in some of the earlier slides. I know, for example, illegal coal mining in Colombia have got really, really big problems. In terms of the decarbonisation, are those sorts of illegal mining issues as big or bigger problem or lesser problem compared to some of the ones we know about illegal mining?
Well, you have mentioned gold, for example. No? For perception in the public, in most of our countries, all the gold, most of the gold is produced in this way. People don't know that this is not this gold produced in the way that you are saying, illegal. It's more or less, is between 10 and 15% of the world gold in the mined in the world. But it gives money, it gives jobs, very bad jobs, to millions of people. So it's a social problem. It's not a mining problem. But of course, this is damaging the whole image of the mining industry, and it's very difficult to. We are looking that to have metals in the future, we need public support, that they understand things can be done correctly, and we need the metals for some time. And that is exactly going in the contrary direction. It's a big problem, but it's a social problem.
Thank you.